we're going to start with a little warm up today just to, get ourselves in gear, get things moving, get thinking about calc, but in a different way today. So our warm up is going to be a game of calculus Jeopardy. So we are told here that the derivative of a function is being given. And then our task is to figure out what was the original function. So, like the game show Jeopardy, the answers show up on the screen, and then the contestants have to say what the original question was that had that answer. So here it's like these derivatives are the answers, and we have to say, okay, what was this the derivative of? So we're like going back to the original type of thing. So let's try it. All right, first one here. F prime of x, so here's our derivative, is 3x squared. What was the original function? Who's got it? I heard someone there for a second. And then I lost you.
Is it x cubed?
It is x cubed. Who was that?
This is Natalie.
Natalie, yay, you got it. Nice. So f of x is x cubed. Very good. All right, because yeah, the derivative of that is 3x squared. Spot on. Okay, now let's see who can get our next one. Oh, Felipe's already putting in an answer. So g prime of x was -4 cosine x. And Felipe says g of x is 4 sine x, which is so close, Felipe, but not quite. He needs one little change. Who's got the change here? What do we need to do with that function? Yeah, Jared's got it there. So make that negative, Felipe, -4 sine x, and then our derivative would be -4 cosine x, because derivative of sine is positive cosine. So 4 sine x would become 4 cosine x. But if we go negative with that, then we'll have it -4 sine x. Cool. So team effort on that one. Very good, guys. Okay, last one here for this round. H prime of x is -1/2 cosecant x cotangent x. What do we think there? Who's got the original H? Yeah, Natalie again. Nice. All right, 1/2 cosecant. I assume you're meaning cosecant x there, and that is correct. So h of x is 1/2 cosecant x, because that 1/2 comes through as a multiplier, and then the derivative of cosecant x is negative cosecant x cotangent x, so it covers those other parts of the function. So yeah, very good, guys. All right, so you're kind of getting used to here thinking about things backwards, going back from a derivative to the original function, or from this function kind of taking a step back. Now, there is one little extra detail that we could put on these. For instance, notice how here in part A, Natalie had our answer there, f of x equals x cubed. That was correct. So while this is good, there is actually another function that could also work. How about like x cubed plus 2? That would work, right? Because if we take the derivative, we'd still get that 3x squared, and then the plus 2 derivative would just be plus 0, so the derivative is still 3x squared. So interesting. And then, I said there was one other that worked. That was a little bit of a lie there. It doesn't have to be plus 2. What if I said plus 85? That would actually still work as well. Okay, so derivative would be still 3x squared. Derivative of 85 is 0. Okay, so that would work. And what if we did like x cubed minus 16. That would actually still work as well, right? 3x squared, and then we'd have minus 0. So that would still be okay. So what we've got here in black for our answers, those are right. So this is good. You guys, you won this round of Calculus Jeopardy. I think Natalie took the lead with 2 out of 3 of those, by the way. Good job, Natalie. But there is other functions that will work for these. So we could do x cubed for this first one, but technically we could also add or subtract any constant on there and it would still work out. So to kind of encompass all those different options like plus 2, plus 85, minus 16, we just say generically plus c on the end of that function to say like, okay, we could have stuck some constant on the end there and the derivative would still turn out the same. We can actually do that to each one of these. Add any constant on the end there. Okay. So there was no way to really know about that in advance though. So I think you guys won.